let me introduce myself first. My name is Yuzhu Lu. I am a user interface developer in Wolfram Research. So today I'm going to talk about some of the updates of existing feature and some of the some of the performance optimizations. I'm going to talk about some of texture updates, shading updates, and we have some 3D rotation gesture improvements, and also 3D notebook scoring and loading. And we also improved a little bit the 3D bounding range with a visible range to reduce the white space in the default case, and also hit testing, printing, rendering performance improvements. There are quite a few. Finally, I'm going to talk about the updates of surface appearance. So texture, we have extended our texture to quite a few more 3D primitives in 12.1, and in 12.2 we're also keeping extended it to 2 more primitives, rectangular disk. Since currently texture objects is being redesigned, so currently by default it's not available, but you can still access through surface appearance. So here's the example of the rectangle. The vertex texture coordinates applying to the rectangle. It works with different options of the rounding radius. You can rotate it, you can scaling it. Here's the example of disk. You have the flexibility of defining the part of the disk and also apply a transformation to it. Shading, we introduced a bunch of shading and filling in 12.1 to have the MPI rendering capability. And in 12.2, we also add 3 more fillings, which is linear gradient filling, radar gradient filling, and conic radial filling. Let's first look at the linear gradient filling. As the name indicates, you can interpolate doing the linear interpolation. So you can give the scaled value, and each position will specify different colors to it, and it will interpolate. Other than that, you can also okay. The dynamic, okay. It will the second argument is angle. You can also rotate it, and also you can also extend it. The third argument is extension. Let me see if this evaluates. Okay. Let me try a different color. Let's see. Okay. Let me switch to my debug build. I think there's something wrong with the current Mathematica I'm using. Okay. Okay, let's continue. So let's come back to the linear gradient filling. Okay. Okay, so yeah, I think there's some bug there, and we'll fix that. So let's go to the examples. So if it should currently spoken, it should work with different color data. Let's see if I do different number. Yeah, it works with all the color data, and you can also specify the different color space. For example, you can do the RGB color space, and also you convert it to lab color space. The things difference is if you are using lab color space, we're going to interpolate in lab space instead of RGB space. It should, like other shadings and fillings, it should work with all the plots and all the bar charts. So yeah, 3D rotation. So the default arcball is the default gesture for graphics, but it has a limitation that it only limited within the bounding box. If the mouse moving outside the bounding box, and the rotation stops. This makes the control of a long thin object, rotating that being difficult. But now in the new version 12.2, we extended it so that it goes outside and it continues. And also we improved that sometimes it has some image size jump, and we have been improved it so that it jumps slowly instead of sudden jump. And meantime, also we add several new arcball gestures for experiment. So for example, this one has both X, Y direction control. So like if you rotate this, you don't need to stop. If you move to vertical space, it will just respect at any position. The current one does not do X, Y direction. It reference back to the original position so that it come back to the original camera if you move back. But this one is the one we're experimenting with. It gives user more control that while rotating, it just respects both X, Y direction. Notebook scoring, we did some optimization of image cache. There are fixed a few issues so that to make sure the image cache has been maximally reused. So for example, before I had 69 3D testing cases. Some of the cases containing raster 3D, which is supposed to be expensive, but it was only saved like 5 image cache, and now it saves more for those cases. So you can imagine that the loading speed of that it should be improved, and also scrolling that notebook containing a lot of 3D graphics, it will be much faster because it has been maximally reused image cache. Bounding range. Some of you have already used the shrink wrap to cut the white space. So you might wondering where are those white space coming from in the default case. So we are doing, for performance reasons, we don't want to project all the points to compute a visible area because there could be millions of points there, and we don't want to make our rotation much slower. So we did before we did a bounding box computing and project those bounding box, but now in the new version we're also computing the bounding sphere and bounding cylinder. So you can see the spherical or cylinder shaped like a cylinder objects will be much tighter and compared to version 12.1, and the other objects could also have some benefits of that. And here is an example of some round-like objects. You can see some of the cases they might still have some, but it's getting improved and without no much performance cost. Hit testing. What is hit testing? Hit testing has been used for all selection, interaction, and it could be very expensive if there's millions objects there in the single box. And so how do we optimize them? And we're now using a quad tree. What is quad tree? Quad trees split your space into 4 subspace and keep going on, and depends on the objects you have. So of course we cannot do so for example, if there's only one object, we don't need to do multiple layers of these nested tree. So how do we determine the nested level? Considering there are most of the objects are uniformly distributed on the screen. So we're using the log 10 of the object number. For example, like 500,000 objects, it we're using 5 level. So the leaf is roughly about 1,000 quad trees there. And if they are distributed roughly uniformly, so each quad tree will contain about 500 objects. So then when you doing clicking and selecting, it will just only look at to the right quad tree, the sub quad tree, and do the minimize the computing. Thus you can improve the performance. For this example, this is the list density plot example from user. Contains 0.6 objects, triangles there. And so originally you have to do 0.6 hit testing to go through all the objects. And but now you only need to do like a 900 hit testing. It's roughly 1,000 times much less. And so for this example, and this makes the editing of the large data set and the interactivity of large data set possible. I tried this on 12.1 on my same laptop. It it is being taking like a half an hour, it's not responding. It's because of the rendering and the head testing. It's going back and forth. It's kind of like a dead loop, has some interfere with each other. But you can do this now with the improve the head testing performance. We do the same thing for 3D as well. Here is the example. It's two surfaces. Each surface contains 0.5 million objects. And so each object will contain 5-level octree. Octree is a little bit Z direction. It has a 4 more subtrees as well. So you can think each subtree, it might contain like a 200 objects. But since it's in 3D, is some of the quadtree might overlap in depth. So roughly it reduced to 200 to 700 hit tests. So still roughly it's 1,000 times optimization. So you can see it's much faster in 12.2. And because of this hit testing optimization, we can do more precise hit distance computing, so that we know exactly which object we hit, which exact triangle we hit. And then it gives the right response. Printing, since version 6 introduced we have been using software Mesa for printing on all platforms. The reason for that is it will interfere with the on-screen. Otherwise, it will interfere with on-screen rendering, and we don't want that. And in 12.2, we figured that out, and then so we are now using hardware printing driver, hardware driver for printing. This should affect all 3D graphics or a subset of 2D graphics printing, saving as PDF or other image formats, or if you want to copy it to other applications like Mail or Paint. I have some rough number. I randomly selected 133 testing graphics. There are several raster 3D and also 2D graphics as well. Took 40 minutes to saving as PDF, and now only takes 35 seconds. That's the difference between the hardware driver printing and also the Mesa. And other than the printing performance improvements, we also did several rendering performance improvements as well. Remember we mentioned the graphics cache, and we did that for 2D as well. And so for those like the not necessary case, not expensive case, we just we don't do the image cache. So this improves the performance of the 2D graphics, manipulate, animate, dynamic if it has a large image. The bigger the image size, you said, the more difference you will notice that. So now the performance, the general performance of manipulate and animate and with those graphics will be improved by from 15 to 33, roughly 40%. And if I show the frame rate, you can see it will currently it's running other application. If we just run this example, you will see the frame rate jump to 23. And Vertex 2D polygon with vertex colors. This is the case used by most visualization functions through the color function case. And we also optimize that. This is the same example I showed you before. Before it takes like roughly 4 seconds to render the first time, and same after. And now it only takes 0.6 sec render first time, and it will like take only 0.5 seconds after. This is roughly 6 to 8 times performance improvements. This should affect all the all the visualization functions plots with color function. The larger image, and if you zoom in a large image and the REST 3D, the performance has been improved as well. Before, even with the clip range, it's the invisible pixels still somewhere there still is quite expensive, and we now doing the visibility check, and only those are visible, so the performance now improved roughly from 0.6 to 13 frame rate, and it should be much faster. Geometry transformation, we optimize. This is a very widely used example. I mean, here is a list of like 25 by 25 by 25 cubes there. The performance has been improved from 1.5 to 27, and it's also roughly 20 times performance improvement. If before we had some problems with combining REST 3D or image 3D together with other transparent 3D objects. Now we're doing a new method called bounded volume rendering. So things like this, if you want to combine image 3D together with other transparent object, it will be much faster. Now, roughly it's like roughly 4 times faster. Surface appearance, we did have several updates, and so now it could take GL Salon file directly and just place it in the working directory, and specify to the right fragment program and vertex program. And I take some example from this online resource, and this is quite simple. And when you look at that, it just makes use of the vertex and vertex textures. And to make it work, you just need to tell our surface appearance that you are going to use a vertex position and the vertex texture coordinates. Of course, you need the transformation as well. Yeah, it has a transformation as well. So specify that, and it will just work with let me take a look. Okay. Yeah, I believe the same reason as the surface, the fillings, the broken. I think there are something wrong with my build, but yeah. So roughly, it just you give this piece and it will just works. And you can also try it with other resources like this on this website. It gives a list of like digital arts, and it also has the GeoSlong source code there. You can just took it and notice that it only has 2 parameters here, times and resolution, and we can reuse our vertex shader and also the feeding in the new fragment program you found, and give the define the 2 parameters, time as resolution, and it should just works. I think. Let me try and see. What's going on here? Yeah, I think there's something wrong with my build. So so more graphics talks. We James Lay were talking about some new and experimental features for 12.2, and that's right after this talk. And so yeah, so that's a talk. And let me see if there's some questions. Okay, yeah, so okay, that's it. Thanks. Bye.